Ever gaze out at the ocean and wonder how those massive ships stay afloat? It's a question that has puzzled many, and today we're going to dive deep into the answer. The secret lies in a principle we've all learned in school, but might have forgotten about. It's called buoyancy. Buoyancy, in simplest terms, is the force that allows objects to float in fluid, be it water or air. It's the reason why a tiny pebble sinks to the bottom of a pond while a colossal ship, weighing thousands of tons, floats on the surface of the ocean. It's the same principle that makes a hot air balloon rise in the sky. This force of buoyancy, which seems to defy gravity, is the cornerstone of shipbuilding and maritime navigation. From ancient wooden rafts to modern steel behemoths, the principle remains the same. As simple as it may seem, the science behind floating ships is fascinating. To comprehend how ships float, we must first understand the principle of buoyancy. Buoyancy is a force exerted by a fluid that opposes the weight of an immersed object. It's a concept that was famously discovered by the Greek mathematician Archimedes over 2,000 years ago. He noticed that when an object is submerged in a fluid, it seems to lose some of its weight. This perceived loss in weight is due to the upward force that the fluid exerts on the object, which we now call buoyancy. Let's dive a bit deeper into how buoyancy works in water. When an object is placed in water, it pushes the water away or displaces it to make room for itself. The water, in turn, pushes back with a force equal to the weight of the water displaced. This is what we call the buoyant force. If the buoyant force is greater than the object's weight, the object will float. If it's less, the object will sink. So how does this relate to the weight and volume of an object? Well, the weight of an object is the measure of the gravitational pull on that object. The volume, on the other hand, is the amount of space that object takes up. If an object has a large volume but a small weight, it will displace a lot of water but will not be pulled down strongly by gravity. This means it will float. Conversely, an object with a small volume and a large weight will not displace much water and will be pulled down strongly by gravity, causing it to sink. When it comes to ships, they are designed to displace a large volume of water. Despite their heavy weight, they displace enough water to create a buoyant force that's greater than their weight, and that's the magic of buoyancy. So a ship floats because it displaces a volume of water that weighs more than the ship itself. Now, let's apply the principle of buoyancy to ships. Ships, whether they're small fishing vessels or colossal cruise liners, have one thing in common: they float. And it's not just because they're lighter than water, it's because of their design and how they displace water. The ship's design plays a pivotal role in its buoyancy. A ship isn't just a solid block of material. Instead, it's more like a hollow shell, with the majority of its volume being empty space. This structure, especially the ship's hull, is key to its ability to float. The hull of a ship is shaped to displace a large amount of water. It's broad and wide, allowing it to push aside or displace a significant volume of water. But it's not just about the amount of water displaced, it's about the weight of that water. According to the principle of buoyancy, when an object is immersed in a fluid, it experiences an upward force equal to the weight of the fluid it displaces. So the hull of a ship is designed to displace an amount of water that weighs the same as the entire ship. Consider a ship that weighs 100,000 tons. Its hull is designed to displace 100,000 tons of water. This displacement creates an upward force or buoyant force that supports the weight of the ship. If the ship weighs less than the water it displaces, it floats. If it weighs more, it sinks. But remember, it's not the ship's weight alone that determines if it will sink or float. It's the relationship between the weight of the ship and the weight of the water it displaces. That's why even a heavy steel ship can float. Its hull displaces enough water to create a buoyant force equal to the ship's weight. It's the ship's design and displacement of water that keeps it afloat, not simply its weight. You might be wondering, what about the materials ships are made from? Well, you're in for a treat because ship materials play a pivotal role in ensuring these mammoth structures stay afloat. Let's start with the basics. Ships are primarily made from materials that are both lightweight and robust. They need to be strong enough to withstand the force of the waves and the load they carry, yet light enough to keep from sinking. The most common material used is steel, which boasts a fine balance between weight and strength. It's heavy, yes, but because it's spread over a large area, it doesn't cause the ship to sink. Now you might be thinking, but steel is heavier than water. How does that work? It's all about displacement. The weight of the water displaced by the ship needs to be greater than the weight of the ship itself. Even though steel is denser than water, the hollow shape of the ship allows it to displace enough water to keep it afloat. But it's not just about steel. Ships also incorporate other materials. Aluminium, for instance, is often used in the construction of smaller vessels due to its lightness and resistance to corrosion. Then there's wood, which has been used for centuries due to its natural buoyancy, though it's less common in modern shipbuilding. And let's not forget about the role of composites. These are combinations of two or more materials that, when combined, offer superior properties. For example, fiberglass, a form of composite material, is often used in yacht construction due to its strength, lightness, and resistance to water damage. In essence, the choice of materials in shipbuilding is a delicate balancing act between strength, weight, durability, and cost. Every ship, from the smallest dinghy to the largest container vessel, is a testament to the marvel of engineering and the profound understanding of material science. While the materials a ship is made from are important, it's the overall design that truly determines its buoyancy. So, let's summarize what we've learned about how ships float. We started with the principle of buoyancy, the fundamental force that keeps ships afloat on water. This principle, discovered by the ancient Greek mathematician Archimedes, states that any object, partially or wholly immersed in a fluid, is buoyed up by a force equal to the weight of the fluid displaced by the object. In simpler terms, for a ship to float, it must displace an amount of water that weighs the same as the ship itself. This is why even a heavy metal ship can float on water. As long as the weight of the water it displaces equals or exceeds the weight of the ship, it will stay afloat. Next, we delved into the role of ship design. The shape of the ship, specifically its hull, is crucial in determining how much water it displaces. A wide, flat-bottomed hull, common in most large ships, displaces a greater amount of water, thereby increasing the buoyant force and helping the ship to float. The material choice for the ship also plays a significant role. While it is true that metals like steel are denser and heavier than water, they can still be used to construct ships. This is because the ship, as a whole, is less dense than water. The air-filled spaces within the ship, like its cabins and hollow hull, decrease its overall density, allowing it to float. In essence, the science behind floating ships is a delicate balance of physical principles, innovative design, and material selection. It's a testament to human ingenuity and our ability to harness the laws of nature to our advantage. So next time you see a massive ship cruising across the ocean, you'll know exactly why it doesn't sink. We've navigated through the science of floating ships. Together, we've plunged into the depths of buoyancy, explored the role of ship materials, and unraveled the mysteries of how these colossal structures defy gravity to float on water. It's been quite a voyage, hasn't it? Now, as our journey comes to an end, consider those around you who might also be intrigued by this fascinating science. Perhaps you know a maritime enthusiast or someone who loves to question and understand the world around them. Don't hesitate to share this voyage of discovery with them. After all, science is a journey best shared. As we dock at the end of our journey, take a moment to appreciate the science that surrounds us every day. Whether it's a ship sailing smoothly across the ocean or a leaf floating gently down a stream, it's all buoyancy at work. Remember, the world is full of science, even in places you'd least expect it, like a ship floating on the ocean.